Hi everyone. In this video, we're going to learn about how to take the derivative of the e to a power. So a power, that's a variable. So natural exponential functions. Just to remember a few rules about the letter e. If you were to multiply a base e to a power and another base e to a different power, you add the powers together. And if you're dividing e to a power divided by e to another power, you would subtract those powers. We already started this process, but we need to learn this one limit before we move on. This limit, if we were to do this analytically, it would be beyond the scope of this course. So I would just like us to find it with our graphing calculators by looking at the graph and looking at the table. So the limit as h approaches 0 of e to the h minus 1, all of that divided by h. We'll do that on our calculators by substituting an x in for h. So let's go to the calculator screen here. So here's the function. If I look at the graph of it, in a standard window, it looks like it's going through at x equals 0. So as the limit goes to 0, it looks like it's going through a 1. And if I look at a table, as I get really close to 0, it looks like it's approaching 1. When I plug in 0, we're going to have undefined, though. So based on that, we are going to say that the limit of this is 1. As h approaches 0, our limit is 1. So we're going to use that information, and we're going to use it to find this limit right here. Well, if we look at this limit, this is the definition of what a derivative is. F of x plus h minus f of x all over h as h drops to 0. So f of x plus h is right here, where the x is going to have that x plus h. This is f of x, the original function, as h divided by h drops to 0. Our properties of exponents would mean I could separate this into e to the x times e to the h. And now I have an e to the x in both terms, so I could factor that out. So I have e to the h minus 1 over h. Now, if we look at this limit, it's the limit as h approaches 0. E to the x has nothing to do with an h. So that's not going to be affected by my limit at all. So this limit, I can actually take the e to the x and throw it out in front of the limit. And now if we scroll back up, we know what this limit is. E to the h minus 1 over h is 1. So that leaves us with e to the x. That limit is 1. So the derivative of e to the x is e to the x, the same exact thing. The part that you have to remember is if that's not an x, we have to do a chain rule. So we'll have to find the derivative of whatever is up there in the exponent. So here's the rule written out for you. The derivative of e to the x is e to the x, or e to another function is e to that function and the derivative of that function. So let's do a couple examples here. So the derivative would be the function. And now I need to do the derivative of this. So negative 3 to the x minus 1. We will drop down the negative 1. So that would become a positive 3. And that'd be x to the negative 2. So rewriting that a little more formally, that would be e. Specifically, this is a negative power, so let's do that as a big fraction bar. E to the 3 over x. And that 3 doesn't have a negative power, so that's going to go in the numerator. So 3 is in the numerator. And x squared is in the denominator. In this next example, we're seeing e to the x power and another e to the x power, and that's being divided. So we're going to have to use our division or quotient rule. So that's low d high minus high d low. Over bottom squared we go. So low, e to the x plus 1, d high, That's going to be multiplied by e to the 3x, and then derivative of that power, which would be 3, minus high d low, which would be the derivative of e to the x plus 1, which is e to the x. Derivative of x is just 1, so I don't need to write that multiple of 1. And then derivative of my constant 1 is 0, so I don't need to write that. And that's all over bottom squared we go. So e to the x plus 1, all that squared. We can go ahead and distribute this inside of the parentheses as well as the 3 if we wanted to see if anything will reduce. And we get 3e to the 4x plus 3e to the 3x minus e to the 4x, still over our same denominator. And it looks like we have e to the 4x, we have minus another e to the 4x, so we could say we have 2e to the 4x's and 3e to the 3x's. And we would probably want to factor out an e to the 3x just to make it a little more clean cut, but that is an appropriate answer. The next one, you should go ahead and try and see if you get the same answer as me. Derivative of e to the 2x minus 1 is e to the 2x minus 1, and derivative of its power is 2. Try this one and see if you get out the same answer as me. This is a product rule, so derivative of the first times the second, and then add that to the second times the derivative of the first. And rearranging some common factors, you can pull out an x and an e to the x. So you get this for your final answer. The integral process of a natural exponential function is also very easy because of how easy the derivative is. So e to the x, the integral of that dx is e to the x. Or you might have to do a slight u substitution if you have a power that is not x. Don't forget your plus c. And this little note is just telling us that the integral of e to the x and also 5.11, which is derivative of e to the x, is frequently tested on the AP exam. So let's practice some of these. Keep that up on the screen. So it looks like my u for this is going to be 3x plus 1. My du will then be 3 dx. So I want a 3 in here, which means I need a 1/3 out here to make it all balanced. So that would make it the 1/3 integral of e to the u du. And the integral of that is itself. And then plugging back, plus c, don't forget that. And then plugging u back in, it's 3x plus 1. The next one, my u is going to be x to the negative 2. My du will be negative 2x dx. So I need a negative 2 sitting in here. I need a 1 over negative 2 sitting out here. And that 5 I really can throw out there as well. So this is going to be the negative 5 halves integral of e to the u du. So that is negative 5 over 2. And don't forget, after you have your function with your plus c, don't forget to put in what u was. All right, trying another one here. I see e to the 1 over x power, so I'm going to use u, or set u, to be 1 over x, which means du is going to be negative 1 over x squared dx. And it looks like I have 1 over x squared dx right here. I just need a negative sign inside and then an outside as well. So this will be the negative integral of e to the u du, which you can see how this all plays out again. So I'm going to skip a couple steps. E to the u is really e to the 1 over x power. and that negative and sign in front, and then plus c to end it. Try these next examples and see if you get out the same answers as me. And here are the answers. If you have any questions, you can save them for the next time we see. And your homework is below. I'll talk to you later. Bye.